Hi, I'm going to talk about the interactive network infection game we developed at Oerstec. We made this game to help us understand the nature of making real-time decisions on defensive strategies in a network environment with limited resources. The game is to perform an SIR simulation and to maintain communications between selected nodes within a network on a graph. We'll begin by making a graph. We could do that manually by adding new nodes and making connections to the nodes using this GUI interface, but it'll be easier for us to let the system create the graph. So we'll start with 30 nodes and an average of 5 connections per node. Make a random graph. Okay, this is okay. We'll round this out a little bit by connecting 30 to say 8. Make that a bidirectional connection. Okay, let's stretch this out a little bit. The software was written in MATLAB, and there's an interface to GraphViz which distributes the nodes onto the figure window. The figure window is a little small, so the distribution can be a little bit tight. Okay, let's go and configure the simulation. We'll start with 2 initial infections. Let's reduce the transfer rate down a little bit. And we're going to have a budget. We're going to use this budget of 500, let's say, dollars to improve the capability of certain nodes within the network. Okay, we're going to require that 2 independent paths be maintained at all times during the simulation. Okay, we're going to select a primary node. I'm going to choose 17 since it has a lot of connections and it's towards the end of the graph, being at the bottom of the graph here. So let's select 17 here, set to primary. You can see the color changes to blue to distinguish it from the other nodes. And we're going to select a few critical nodes. Let's choose 8. Set that to critical, and since it's critical, we're going to give it a little bit more ability compared to some of the regular nodes. So we're going to take money from our budget and we're going to use that to improve its ability to ward off infection and to heal itself if it does get infected. Okay, let's choose a few others. Let's say 1. Set that to critical. Say 24. And how about 13? Okay, let's iterate the simulation and see what we have so far as independent paths go. Okay, we can see that our two nodes have turned red. Those are our initial infections that we configured earlier. And we've got 4 paths established between our primary node and the 4 critical nodes. Let's say there's one path that goes from 12 to 8, a path that goes directly to 1, a path that goes through 2 and 16, and eventually winds up at 13, and another path that goes through a few nodes to get to 24. Okay, let's give a little bit of more capability hill for the nodes that are immediately adjacent to the primary node, since they're carrying more burden as far as keeping the network communications alive. So let's give 12 a little bit more healing ability and protection against infection. Let's also do that for 2. Let's give it some more healing. 1, let's give it some healing and infection protection. 9. And 15. We may need that later as the paths redistribute themselves. Okay, let's iterate the simulation, see what we have. We can see that some of the paths have rearranged themselves. Let's go ahead and try to heal up number 22 here. It's got a lot of connections. It could be useful later. We've got some budget left. You can see that 8 has begun flashing. That's when a critical node becomes infected. It flashes between its critical node color and red. Okay, let's try to heal up 6 as well, since we still got some budget remaining. Okay, we're down to 2 critical paths. That's not a good situation. What do we have here on 19? And 30. Let's try to heal that. Let's try to heal probably 4. So this is the last of our budget. So we're just going to let the sim run out and see what happens. We still got 2 paths. Just barely hanging on by the skin of our teeth. Okay, we're back up to 3. We've got some equilibrium in the system where you see that nodes are healing and then reinfecting. Okay, so we finally reached a point in our simulation where we couldn't maintain 2 paths. So this message popped up and says that 2 paths are required and 1 path found, so we don't have insufficient resources to continue our mission. We made it through 36 iterations. I think our goal was 120 in this case, and we didn't make that, so we failed this time. So hopefully we can learn from that. Well, thank you for watching this. I hope you enjoyed it, and if you have any questions, you can go to our website, oerstec.com. You can leave a message there and we'll get back with you. Thank you.